Hi, good morning, everyone. Welcome to the week three instructor session. Hope your week is going well and that we're midway through the session here in this 6-week session. And we're taking a look at this week, well, extending our work from last week on solving equations. And here, what you see the title here, we're going to be solving equations with multiple steps. So last week, just a quick refresher, you dealt with equations where you were learning the properties of equality, the addition property, the subtraction, the multiplication, addition, division, and where you had what we call one-step equations. So now we're just going to sort of put it all together. Okay, so well, let me kind of do here. So yeah, this is it. Sorry. So we have something like this now where we have multiple items on the page. Let me get my pen. Okay. So multiple items, last week you had something like, 2x equals 15. That's what you had last week. Now the only difference is that we're going to have more stuff included with it. So the question is then, how do we deal with this extra stuff? And just sort of keep in mind the goal and the process with the whole thing is that at the end of the day, we want to get this variable right here by itself on one side of the equal sign. And then everything else, all these numbers have to manage their way over to the other side of the equal sign, and they're going to become something else. Who knows what they're going to be? But that's the whole idea. Variables to one side of the equal sign, everything else to the other side. And so with that in mind, one of the things I hope that that I said last, when we deal with solving equations, the way that I sort of think about this is I do two rules or two rules for the process, okay, if you will. And these aren't really rules, but these are more simplifications of the properties of equality that we talked about last week. One is do the opposite, okay? Now I'm going to put that in air quotes. I'm going to put that in quotes. I mean, not air quotes. I'm going to put that in quotes because do the opposite sort of depends upon the context of the problem. If you're adding, then you're going to subtract. If you're multiplying, you're going to divide, and vice versa. So that's what I mean by do the opposite. And we'll see that through the course of this whole thing. And then the other rule that I have is what I call the golden rule of algebra, which you already know, but you're going to become familiar with it again. Okay, so let's take a look at this problem here and see how we apply these two rules. Okay, so as I mentioned, the goal is to get x on one side and everything else to the other side. So the thing is here, when we take a look at where the x is, notice there's multiple stuff. Okay, so we have a 2 in front and we have a 3 in front, or a 3 with it on the same side. The question is okay, I want to get rid of those, and I think I know how to do it, but what order do I do it? What goes first? What do I have to get rid of first, the 2 or the 3? And generally speaking, whenever you see addition or subtraction, that's what you're going to get rid of first. Generally speaking. So we'll build upon this and we'll see it develop as we go along. But generally, it's something like this. Get rid of the the -3 part first, and then deal with the 2. Okay, so now that we know what we're going to start with, we can apply our two rules here. So focusing on the 3 here, we want to quote unquote do the opposite. Well, what's going on? Notice that the 3 has a minus sign in front of it. So what's the opposite of minusing 3? Well, we're going to add. And what are we going to add? We're going to add the exact same thing. We want to do the opposite of that. Opposite of -3 is +3. That's what that means right there, is whatever you're doing at that moment, do the opposite of that, whatever you're trying to get rid of. And now the golden rule of algebra. Now, it's something that I made up. It's not actually a rule of algebra. It's just something I coined to kind of keep it straight in my mind, which you already know. But what's the golden rule? Do unto others as you want done unto you. Treat people how you want to be treated. Well, in this context of algebra, the golden rule is what you do to one side, you got to do to the other side as well, the other side of the equal sign. So if we're going to add 3 to one side of the equal sign, we add 3 to the other side of the equal sign. And now we do that. So here's what happens is by design, when we combine the -3, the -3 and the +3, that's going to combine to give 0 and go away. That was our purpose. That was our goal. We're trying to get rid of it. And so that's just going to leave the 2x that's going to pop down on its own. Bring down your equal sign. And now you do the addition here. 15 plus 3 gives us an 18. Okay, so, well, okay, then we're going to finish it up. So now we're right here, and this is what you did last week. 2x equals 18. This is a one-step equation. We recognize that this is 2 times x, and so we go back to these steps right here. What's the opposite? Well, if we're doing 2 times x, then the opposite of multiplying by 2 is what? Dividing by 2. And then the golden rule of algebra says do it to both sides. Okay, and so now we do the simplification. These 2's here cancel by design. That's why we divided by a 2. So that gives us the x that we want. Look at that. It's by itself on one side of the equal sign. And then simplify the 18 over 2, and we get a 9. And that's the answer. Okay, so I'm going to do one more like this. And I'm gonna make one observation after I do that. So these are sort of the steps, okay? This is sort of the framework that I have in mind when I do it. Do the opposite and golden rule of algebra. And what you have to do is when you see addition, subtraction, get rid of that first, and then get rid of the number that's in front of the x last. That's kind of the general process. So let's see this again in another example. Boom, here we go. Okay, 3x plus 7 equals 25. So remember what I said. If you have addition, subtraction, get rid of that first. So we're going to start off with doing that. So we're going to have this minus 7, and we're going to do the opposite. So opposite of adding 7 is subtracting 7. And you got a golden rule of algebra and do it to both sides. So these things here cancel. They go to 0 by design, leaving that 3x there by itself on the left side. And then we do this subtraction right here, 25 minus 7, and that gives us the 18. And then finally, we got to get rid of this 3. Remember, this is 3 times x. So we do the opposite of multiplication, which is division, and we're going to divide by that value in front of the x. Golden rule of algebra, do it to both sides. And so we simplify each fraction, giving us 6. Okay. So that's generally how it works. Get rid of the addition, subtraction first, and then get rid of the number in front of the x last. That's kind of the general process. And we'll develop this a little more and see some more steps. So at this point, though, we're gearing up for another piece of the puzzle here, and I want to make a brief little note about this step right here. Notice the effect is we wanted to get rid of the 7, and we wanted to move it over here, essentially. So the thing to take note of is that in order to move a term from one side of the equal sign to the other side of the equal sign, you can't just move it. You got to do the opposite. You got to add the opposite or do the opposite. So this is a critical step right here, and we're going to see it in a different context in just a second. But this is the key piece here. So let's see that. I think we're ready for it now. Let's see if I can find it. I'm going to find it. Where is it? This is it. This is the one I wanted to get to. Okay, suppose we have something like this. Now, this is a little bit different. Oops. This is just a little bit, this is not a big deal, a big difference between what we did. Notice what we have, though, that's different is that we have variables on both sides of the equal sign. That's okay. We know how to deal with this. You just need to be told what it is. Again, it's still the same goal, trying to get the x by itself on one side, everything else on the others. Now you can, does it matter what side of the equal sign you get the x on? No, but I tend to, ever since I was, 13, 14 years old. So for the past 35 years, I've always done get the variable to the left-hand side. Does you have to do that? No, but it just I make it a rule in my own head so that I don't have to think about it later on. That's just it works every time. So what I recommend is when you have variables on both sides like this, get one and move it over. Now you can't just move it over. This is what I was talking about at that last problem is if you want to move a term over, you've got to do the opposite. You got to add the opposite. So what's the opposite of negative 2x? Well, the opposite is positive. So we're going to add the 2x. That's how you move a term from one side of the equal sign to the other side is you add its opposite. And now we have the golden rule of algebra, do it to both sides. And notice I lined up the 2x underneath the 4x. I lined up the like terms with each other so that when I go to add them, I'm basically I'm telling myself I'm going to combine those two terms. And so when we do that, so now we're ready. combine the like terms here. And so 4x plus 2x gives us 6x. This plus 5 here is just going to come down. It doesn't change. And this minus 13, don't forget that minus sign in front. Candidly, I forgot that a lot of times. So that's why I mentioned it. And that minus 13 is just going to come down as well. Now look at that. That's something we know how to do. That was the last problem. Excuse me. So what we're going to do then, get rid of this 5, do the opposite. It's the same thing. We want to take this 5 and move it to the other side of the equal sign. So you got to do the opposite. So you got to subtract. So these 5s here cancel, leaving the 6x on the left side. Minus 13 minus 5. Always check your calculator. Check it on your calculator too if you want. Gives us a minus 18. And then we finish up the problem by dividing by 6. Divide by 6. And so that yields the final answer. I'm going to come over here with it. X equals -3. Boom, boom, boom. Okay. So here, when you have something like this, you want to take the variable and move it over to the other side. And remember, the key is, the way to do that is add the opposite. Okay, so what we're doing here is we're just taking the basic problems that you already know how to do and just adding little elements to each of those. So let's see this one more time. See this one more time. Okay, so here we have a 6y on the right-hand side. We want to take it and move it over, but we can't just move it over. We got to add the opposite. So in this case, though, this is a positive 6y. So what's the opposite of positive 6y? Negative 6y. Just change the sign. And you do that to both sides. So now we combine those. So the 8y minus 6y here is going to give us 2y. This minus 3 just goes down. This plus 17 just goes down. Now we got to get rid of, excuse me, the 3 here. And we got to do the opposite. So now, because there's a plus sign in front, we do the opposite of that. So we're going to add 3 to each side. So now those 3's cancel on the left side, leaving a 2y on the left. 17 plus 3 is 20 on the right-hand side. And then we finish up by dividing both sides by 2. And so that yields the answer, what? Y equals 2. Okay. So that's that's how you deal with it. Pardon me, class. I have a lot of allergies today. That's how you deal with it when you have variables on both sides of the equal sign. Okay, and so there should be, yes, now we want to add a little more to it, a little more to it. Now, notice we have variables on both sides, so that's not new. We know how to deal with that. But what is new? We have parentheses now. We have parentheses. And so when you see parentheses, that's what you want to get rid of first. That's what you want to get rid of first. So how are we going to do that? Well, remember from last week's material, we talked about the distributive property. And so you're going to take this 2 over here and multiply it inside the parentheses, multiply that 2 to the y, and then multiply that 2 to the 10 right here, and then bring down the right side. So this gives us then 2y, well, let me do this, type it, it's a little easier. Gives us 2y plus 20 equals 8 minus 4y. Okay, so now this is exactly what we were working with before. We have a y over here that we want to get rid of and move over here, okay, over to the left-hand side. So how are we going to do that? Well, it's a minus sign in front, so add the opposite. So that means we're going to add a positive 4y to each side and line up your like terms. So that gives us 6y on the left plus 20. And then on the right-hand side, we just bring down the 8. Now here we got to get rid of the minus 20. So we're going to get rid of that by doing, so we're going to get rid of the positive 20. So we're going to get rid of that by subtracting 20 from each side. So now I'm going to shoot over here. I'm running out of space. So that becomes 6y on the left, because the 20s here cancel. And then 8 minus 20 on the right gives us a negative 12. And then we finish up by dividing both sides by 6. And that gives us negative 2. Pardon my handwriting. Okay. So I think maybe there's one more. Oh yeah. Is there one more? Well, we can do another one. Let's see. Oh yeah, let's do one more like this. Yeah, let's do one more like this. And then I have one more after that I want to do. Okay, same thing as before. We got the parentheses. We got to get rid of those. Whenever you see parentheses, get rid of those first. Really helps you out with the process, makes it a lot easier. So take the 6 here, multiply to each term on the inside. So 6 times z is 6z plus 6 times 4 is 24. Bring down the equal sign. And then the right-hand side, so minus 16 minus 4z. Okay, now it's time to take the z's and move it over to the right. And we add the opposite. So here we're going to add a 4z to each side. Add 4z. And so when we do that, we get 10z plus 24 equals negative 16. Now we take that 24 there, and we do the opposite of that. We're moving it over. And so then when we do that subtraction, we get 10z equals negative 40. 16 minus 24 is negative 40. And so divide both sides by 10. I think you all can see that now. And that gives us negative 4. Okay. So now there's one more problem type we need, and we'll be done. Where you'll have seen virtually everything that you need. And that is this type of problem. Boom. How is this one different? It's not too terribly different from what we did. We still have parentheses, so we're going to need to get rid of those. So what's different? That's if parentheses isn't the difference, what's the difference? Look at what we have here. We have x's on the same side. So we'll talk about we don't do those right away, but we will do those here just shortly. So first things first is we got to get rid of those parentheses. Okay, so get rid of them here. Okay, take that negative 4 multiplied inside. And so we're going to get 2x plus 3x plus 2 on the left hand. We're just going to bring it down. Negative 4 times 3 is negative 12. Negative 4 times minus x is plus 4x. Okay, so don't forget that the number one mistake here is that minus sign here, that not changing the sign. By the way, where do we get that? We got a minus sign here and a minus sign here. Those will cancel to get the positive right here, by the way. Okay, so now we're ready. We got the parentheses gone. Notice here we have 2x plus 3x. Because they're on the same side of the equal sign, we can just go ahead and combine these to give 5x. So this whole notion, just a kind of a reminder and a refresher, this whole notion of doing the opposite when we want to take this 4x and move it over, we have to do the opposite. The reason is because it's on the other side of the equal sign. When you have x values or variables on opposite sides of the equal sign, that's when you have to, quote unquote, add the opposite, do the opposite. When you have the variables on the same side of the equal sign, you can just go ahead and combine like terms. That's the difference. That's between those things. So we're going to combine these to give 5x, 2x plus 3x, and bring everything else down. And now notice it converts into exactly what we've been doing. So now we take this 4x here and we're going to move it over, but that's where the opposite comes into play. So we subtract 4x from each side. Oh, this is going to work out nice. Excuse me. X plus 2 equals negative 12. Now here we got to get rid of the 2. Well, how do we get the x, by the way? 5x minus 4x yields 1x. And so I just dropped the 1 because it's implied, just to give you a heads up why I did that. Okay, and then subtract 2 from each side. And so that's going to give us a final answer. Let's come over here because I'm running out of space. X equals negative 14. Boom, 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 boom. And that is it. That is it. Notice out of all this, we just layered these things one thing at a time. And so is there a general process? Something to keep in mind. And there is. And here it is right here. Clear the parentheses. If you have parentheses, you won't always have parentheses, but if you have parentheses, get rid of those first. Apply the distributive property, get rid of those parentheses. And then notice in that last problem, like we had, if you have like terms on the same side of the equal sign, go ahead and combine those two. Those would be the things you would do at the initial step. Once you do these two things, then you will add the opposite to move terms from one side of the equal sign to the other side of the equal sign. So you're going to move your variables when you have variables on the opposite side of the equal sign, add the opposite to collect them to one side of the equal sign. And then same thing with the uh, uh, numbers, add the opposite of those to collect those to the other side. And then yeah, that's what step 3 is. And then once you finish that up, use the multiplication or division property to get rid of the value in front of the variable to get the coefficient in front of the x to be 1, and you're there at the solution. And then something I didn't do here, but it's certainly encouraged and recommended, and hopefully you do is check your answer, make sure it's right. That's one of the equations are fun because you can actually check your answer and know if you're right or wrong before you ever submit it. So just keep that in mind as well. Okay, well, hope you found this helpful. Let me know if you have any questions on the process. Glad to help lend a hand, and look forward to working with you in the discussion board this week. Have a great day. Bye-bye.